Download this code from codegive.com, link in the description below. Resource Access Control with IAM Roles and Permissions, a detailed tutorial. This tutorial delves into the concepts of resource access control using identity and access management, IAM, roles and permissions. We'll cover the fundamentals, explore best practices, and provide practical code examples to illustrate how to effectively manage access to your cloud resources, primarily focusing on AWS IAM. 1. Understanding IAM and its core concepts. IAM is a fundamental security service that enables you to control access to your cloud resources. It allows you to define who, authenticated identity, has access to what resources, authorization, and what they can do with them, permissions. Here's a breakdown of the key concepts. IAM users represents an individual person or application that interacts with your AWS account. Each user is associated with a unique set of credentials, access keys, passwords, for authentication. IAM groups a collection of IAM users. Groups allow you to manage permissions for multiple users simultaneously, simplifying administration and promoting consistency. Permissions assigned to a group are inherited by all its members. IAM roles an identity that assumes specific permissions. Unlike IAM users, roles aren't directly associated with a single person. They're designed to be assumed by entities like AWS services, example EC2 instances, Lambda functions, ECS tasks. Applications running on EC2 instances. Other AWS accounts. Federated users, example users authenticated via Active Directory. IAM policies documents that define permissions using JSON syntax. They specify effect whether the policy allows or denies access. Allow grants permission, deny explicitly prohibits it. Deny always overrides allow. Action the specific API calls, operations, that are being granted or denied access to, example S3 get object, EC2 run instances. Use the principle of least privilege and only grant the actions necessary. Resource the AWS resource, S, to which the action applies, example a specific S3 bucket, all EC2 instances. Use resource level permissions where possible to restrict access to only the resources needed. Condition, optional specifies conditions under which the policy applies, example only allow access from a specific IP address, only allow access within a certain date range. Principle the entity, user, role, service, that is requesting access to a resource. In an IAM policy, the principal element specifies who is allowed to assume a role. It's most commonly used in trust policies for roles. 2. Why use roles? Roles offer significant advantages over using IAM users with access keys on EC2 instances or in applications. Security avoids storing long-term credentials, access keys, on EC2 instances or in your code. IAM roles provide temporary credentials that are automatically rotated by AWS. Centralized management manage permissions centrally through IAM roles instead of distributing access keys. This simplifies administration and auditing. Flexibility easily change the permissions granted to an instance or application by modifying the IAM role without needing to update configuration files or redeploy. Auditing easily track who assumed a role and what actions they performed using AWS CloudTrail logs. 3. Creating IAM roles and policies, practical examples. Let's illustrate the creation of an IAM role and policies with a common scenario, an EC2 instance that needs to read objects from an S3 bucket. A. Creating an IAM policy for S3 access. This policy allows read-only access to a specific S3 bucket. Explanation asterisk. Asterisk version asterisk specifies the version of the policy language. Asterisk statement asterisk an array of one or more policy statements. Asterisk effect asterisk allow, granting permission. Asterisk action asterisk S3 get object allows retrieval of objects from the bucket. S3 list bucket allows listing the contents of the bucket. Asterisk resource asterisk the ARN, Amazon resource name, of the S3 bucket and its contents. Replace your S3 bucket name with your actual bucket name. The slash asterisk wildcard refers to all objects within the bucket. Steps to create this policy in the AWS console asterisk. 1. Go to the IAM console, https://console.aws.amazon.com/IAM/ https://console.aws.amazon.com/IAM. 2. In the navigation pane, choose Policies. 3. Choose Create Policy. 4. Select the JSON tab. 5. Paste the JSON policy document above into the text area. 6. Review the policy summary and choose Next. 7. Enter a policy name, example S3 read-only access policy. 8. Optional, enter a description. 9. Review the policy and choose Create Policy. B. Creating an IAM role for EC2 instance. Now, we'll create an IAM role that the EC2 instance will assume. This role needs a trust policy that specifies which service, in this case, EC2, is allowed to assume the role. Explanation asterisk. Asterisk principal asterisk specifies the service, EC2, that is allowed to assume this role. ec2.amazonaws.com is the service principal for EC2. Asterisk action asterisk STS assume role allows the specified principal to assume the role. Steps to create this role in the AWS console asterisk. 1. Go to the IAM console, https://console.aws.amazon.com/IAM/ https://console.aws.amazon.com/IAM. 2. In the navigation pane, choose Roles. 3. Choose Create Role. 4. Select AWS Service as the trusted entity type. 5. Choose EC2 as the service that will use this role. 6. Choose Next. 7. In the Add Permissions section, search for the S3 read-only access policy you created earlier and select it. This attaches the policy to the role. 8. Choose Next. 9. Enter a role name, example EC2 S3 read-only role. 10. Optional, enter a description. 11. Review the role and choose Create Role. See attaching the IAM role to the EC2 instance. 1. Go to the EC2 console, https://console.aws.amazon.com/ec2/ https://console.aws.amazon.com/ec2. 2. Select the EC2 instance you want to associate with the role. 3. Choose Actions, Security, Modify IAM role. 4. Select the EC2 S3 read-only role you created from the drop-down list. 5. Choose Update IAM role. Now, your EC2 instance has the permissions to read objects from your specified S3 bucket without needing to store access keys locally. 4. Code examples, AWS SDK. Here's how you can access S3 from your EC2 instance using the AWS SDK for Python, Boto3. The SDK automatically retrieves temporary credentials from the instance metadata service, which is configured by the attached IAM role. Explanation **** bot03.client, S3, creates an S3 client. Bot03 automatically retrieves credentials from the instance metadata service when running on an EC2 instance with an associated IAM role. You do not need to explicitly configure credentials. ***s3.get_object, bucket equals bucket_name, key equals object_key, downloads the object from the S3 bucket. The code includes error handling to catch potential exceptions during S3 access. 5. IAM best practices. Principle of least privilege * grant only the permissions required to perform a task. Avoid using wildcard permissions unless absolutely necessary. Use resource level permissions * restrict access to specific resources instead of granting broad permissions. Regularly review and audit permissions * periodically review IAM policies and roles to ensure they are still appropriate and necessary. Remove any unnecessary permissions. Use AWS IAM Access Analyzer to identify unused access. Enable multi-factor authentication, MFA, for IAM users * protect your IAM users with MFA to add an extra layer of security. Use IAM roles for applications * never embed access keys directly into your application code. Use IAM roles to grant permissions to applications running on EC2 instances, Lambda functions, etc. Avoid using the root account * create IAM users with administrator permissions instead of using the root account for everyday tasks. Enable MFA on the root account and secure the credentials. Use AWS managed policies as a starting point * AWS provides a set of predefined managed policies that cover common use cases. Use these as a starting point and customize them as needed to meet your specific requirements. Use IAM Access Analyzer * This AWS service helps you identify potentially insecure IAM policies and roles by analyzing their access paths. Regularly rotate credentials * enable automatic key rotation for IAM users' access keys. IAM roles handle credentials rotation automatically. Centralized IAM management * if you have multiple AWS accounts, consider using AWS Organizations and IAM Identity Center, successor to AWS Single Sign-On, to centrally manage identities and access across all your accounts. 6. Advanced IAM concepts. Conditions * IAM policies can include conditions that further restrict access. Common conditions include AWS source IP, restrict access to specific IP addresses. AWS principal tag, control access based on tags associated with the principal, user or role. AWS request tag, require specific tags to be present in the request. Date greater than, date less than, control access based on the current date/time. String equals, string like, control access based on string matching. Service control policies, SCPs used in AWS organizations to establish guardrails that limit the maximum permissions that can be granted in member accounts. SCPs act as an organizational level permission filter. They don't grant permissions, they only restrict them. Cross-account access * IAM roles can be used to grant access to resources in other AWS accounts. This involves creating a role in the target account with a trust policy that allows principals in the source account to assume the role. Federation * allows you to grant access to AWS resources to users who are authenticated by an external identity provider, IDP, such as Active Directory, Okta, or Google Workspace. This eliminates the need to create separate IAM users for each user. 7. Example, IAM policy with a condition. This policy allows an IAM user to upload objects to an S3 bucket, but only if the objects are tagged with a specific key-value pair. Explanation asterisk. Asterisk The condition block specifies that the S3 put object action is only allowed if the request includes a tag with the key environment and the value production. 8. Tools for managing IAM. Asterisk AWS Management Console asterisk The web-based interface for managing IAM resources. Asterisk AWS CLI asterisk The command line interface for interacting with AWS services, including IAM. Asterisk AWS CloudFormation/Terraform asterisk Infrastructure as code tools that allow you to define and manage IAM resources in a declarative way. Asterisk AWS SDKs, Boto3, etc. Programming interfaces for interacting with AWS services, including IAM, from your code. 9. Conclusion. IAM is a crucial component of your cloud security posture. By understanding the core concepts of IAM roles, policies, and permissions, and by following best practices, you can effectively control access to your cloud resources and minimize security risks. Remember to always apply the principle of least privilege and regularly review and audit your IAM configurations. This tutorial provides a solid foundation for understanding IAM, but continuous learning and adaptation are essential as your cloud environment evolves.